Part two of our angle property. So for this question, you see, this is for parallel lines. So you can see, this is easy. They say we should find angle A and angle B. So what will angle A be? What will A become? You could see that angle A, they are vertically opposite angle, right? Angle A is same as 57. Reason because they are vertically opposite angle. So I write VOA. VOA means vertically opposite angle. That's, I state the reason. Vertically opposite angles, and they are equal. So angle A here is equal to 57 because vertically opposite angles are equal. Now, if you take a look at angle B, they also have to find B. B is also what? 57. Reason is not because they are vertically opposite, but because there's another reason. Because they are corresponding. Angle B is also 57 because they are corresponding. So we say corresponding angle C, corresponding angle are equal. Corresponding angles are equal. So B is also 57. So that's just the solution to that question. That's just the solution to that question. Now let's take more questions in this regard. Let's look for more questions in this. I've already explained all of this. These are alternate. This orange, this is alternate angle, this is alternate angle, this green alternate angle. This green and orange, they add up to 180. This and this, they also add up to 180. Okay? They are co-interior angle. Since they are co-interior angle, they will add up to 180 degree. They will add up to 180 degree. And then you have this, you can see the orange color, 180 minus x, is also at the bottom is 180 minus x because they are what? Because they are vertically opposite angles. The green, x, they are vertically opposite angles. They are equal. So we just look for examples to solve. Okay, like you have here. Like we have here, 64. Angle A is 64, angle B is 64. Angle A is 64 because they are vertically opposite angle, just similar to the one we solved just now. Angle B is also 64 because they are corresponding angle. So question 8 is same as question 7, just that the values are different. I draw these two parallel lines. I have a line here. Here is 64. Here is 64. And here is A. And here is B. So they ask us to find A and B. So we say A is equal to 64. Why? Because they are vertically opposite angles. Because they are vertically opposite VOA. Vertically opposite angles are equal. Then we say B is also 64. Angle B is also 64 because they are corresponding angles. Corresponding angle, the one at the bottom here for this parallel line, first line, and the one at the bottom of the second parallel line, they are equal. Reason because they are what? Because they are corresponding angles, CA. Corresponding angles are equal. So we solved that problem. Let's find other problems if we do have. Okay, for this part, the problem finished. We move to the next one quickly. See, they've solved them. A is 64, vertically opposite angles are equal. B is 64, corresponding angles on parallel lines are equal. So we'll move to the next one. Okay, this next one is bearing. I think this one is supposed to be treated like something different. Well, let me see. Do we have much time? What is the time now? Okay, we still have time. I think we should treat this bearing. Do you have bearing in your work? Eh? In your study, there's no bearing, right? Can I skip the bearing?
No, we don't have any exams.
You don't have any exam. Okay, we can always do it when you're after your exams, okay? Because I want us to focus in
Yeah,
the teach.
I think in grade 10, that will be our first quiz on variants and
Okay, do you want me to
trigonometry and
do the berry like explain it, or we move on?
maybe in the summer vacation.
Okay, okay, okay. GK, it's better during vacation. You have long van, right? You are
What?
you are doing IGCSE next May, June, right?
Yes.
Oh, okay. Then if you are doing IGCSE next May, June, I think we okay, don't worry. After this we discuss. Okay, let's move to the next one. You don't want to give us? Oh, this is the last one? Huh? So this scale. You're not doing scale, right? You're not doing scale.
Scale. We're doing. You want me to read out the topics?
Psychotheory. Now we go to psychotheory. This one. Okay? Okay, yeah, we're doing this one as psychotheory. Okay, angle at the center and circumference. Okay, let's go. Psychotheory. Psychotheory. Okay, the first basic theory for this is angle at the center is twice the angle at the circumference. So we're going to look at the first one, which says angle at the center suspended on the same, bounded by the same arc equal to twice the angle at the circumference. Angle at the center is twice the angle at the circumference. That's the first theory we're going to look at. So we say if I draw a circle, here is the center of the circle. Let's say we call here X. Therefore, here will be 2x. Angle at the center is always twice whatever is at the circumference. So the first law or first theorem says that angle, I'll use abbreviation, angles or angle at the center angle at the center in psychotheory if they are on the same arc, but on the condition that they are on the same arc, they're standing on the same arc. Look at the two angles, they're standing on this arc. They're standing on the same arc. First of all, these properties of a circle, you know what is an arc, what is a diameter, right? You know what is a diameter, what's arc, what's segment, what's this thing, or you want me to revise those things?
No, I know.
Okay. not angles actually. Angle is one angle. Angle at the center equals twice meaning twice the angle at the circumference. Twice angle at the circumference. Circumference.
But they have to be on the same arc.
Yes, they have to be standing on the same arc. They have to be bounded by the same arc, or same chord, or same segment. But arc is enough. You just remember the arc, it's enough. The word is enough. Angle standing on the same arc, the one at the center is double the one at the circumference. For example, if you want to solve a problem, let's say I draw this. Okay, let's say we have this is the center. I say here is 130. For example, 130. Then I say, what is x? Find x. If here is 130 degrees. Maybe you bring your test because you will do something when we agree to it. Okay, so remember we say angle at the center, look at the rule. Angle at the center, which one is the center? 130. If you want to solve this, the angle at the center is what? 130 degrees. This one, this angle. This angle is 130 degrees, right? It's twice whatever is here. It's twice this. So I have angle at the center, it's 130. I will say 130 is my angle at the center. Is equal to 2 multiplied by x. Equal to twice. Twice means 2 multiplied by whatever you have at the circumference. What we have at the circumference is x. So I say 2 multiplied by x. So 2 multiplied by x is 2x. So I'll have 130 is equal to 2x. (130) is equal to 2x. So to find x, I'll divide both sides by 2. To find x, I'll divide both sides by 2. So divide here by 2, you get x. Then 130 divided by 2, you get 65. (130 divided by 2, you get 65 degrees. So this angle here, angle x, is 65 degrees. Why? Because angle at the center is twice whatever is here. So if here is 65, if you want the center, you multiply the circumference angle by 2. Circumference angle by 2, if they are standing on the same arc. You can see both of them, they are standing on the same arc. So when you multiply it by 2, this arc. They are both standing on the same arc. So if you multiply whatever is on the circumference by 2, you get what is at the center. If they give you the center, you want to find the circumference, you divide by 2. If they give you the center, you want to find the angle at the circumference, you have to divide by 2. But if you are given angle at the circumference, you want center, you multiply by 2. Is that okay? So this is the property. This is the property that with the first rule. Let's apply it before we go to property 2. Let's solve problem with property 1 first. Before we go to property 2. Property 2 is the angles in the same segment are equal. Angles in the same segment are equal. So angles in the same segments are equal. So before we do property 2 and we look at property 3, for cyclic quadrilateral, add up to 180. Opposite angles in a cyclic, the opposite angle in a cyclic quadrilateral add up to 180. So we're going to look at each of these as a property. Since we've stated the property for one, now we're going to solve example for property one. Like I said at the beginning, you need to know what they call a segment. This shaded portion is called a segment. This line is called a chord. Any lines that runs from one end of the circumference to the other end of the circumference without passing through the center O is called a chord. Then any line that starts from a circumference and pass through the center is called a diameter. Then any line from the circumference to the center is radius. From any part of the circumference to the center is called a radius. Then between two radii, you get what we call an arc. You get an arc, this one. Then we have what we call a tangential line. A line that meets the circumference at a point. A straight line that meets the circumference at a point. And it makes 90 degrees with the radius. It forms 90 degrees with the radius. And we already know how to calculate the circumference of a circle. The circumference of a circle is 2 pi arrow. 2 pi arrow. 2 times pi times radius. Or pi times diameter. Because 2 radius equal to diameter. You can say pi times diameter because 2 radius equal to diameter. Is that okay? So we already know. Then the area of a circle is pi arrow square. The area of a circle is pi arrow square. We know these basics. So let's go straight to the applications of the circle theory. See, angle at the center is twice whatever is here. If you multiply what is here by 2, you get what is at the center. If here is 5, center will be 10. If the angle of the circumference is 20, the center will be 40. Vice versa. If you are asked to find, they give you the one at the center, they give you 80 degrees here at the center. Then to find circumference, you divide by 2, you get 40. Divide 80 by 2, you get 40. However, sometimes they will draw it to confuse you. Sometimes they will draw it like this. Remember what is key, what is paramount is that they have the same arc. It does not necessarily mean this one must be on top of this one. For example, something like this. They draw something like this to confuse you, to know whether you know what you're saying or what you're doing. They want to know whether you know what you're saying or what you're doing. They can draw this for you. Okay, my circles are not too nice, but you have to manage. Okay, you have an angle here. Okay, this one is too ugly. I want to delete it. I don't like it. Okay. Now let's try again. Let's draw a circle. Oh. Okay, now this is a good one. Look at it, almost a perfect circle, right? This is the radius. Let's assume this is the radius. Okay. Okay, now let's see. We draw the one of the radius. See the way they drew this in order for us to be confused. They drew it in order for us to be confused. Here is an angle at the circumference. Remember, whatever here is, whatever this one is, whatever this one is, here will be twice the value. The angle at the center will be twice the value, 2x. The angle at the center is twice the value. So even if, no matter how they draw it, you must understand that the angle at the center is twice the value at the angle at the circumference. The angle at the center is twice the value at the angle at the circumference. So for example, if I say this angle is 70, x is 70, what is the one in the center? The one at the center will be 2 times 70, that's 140. Here we give us 140 degrees. If here is 70, for example. Is that okay? So this is one of the applications of how we apply the angle at the center equals twice the angle at the circumference. Now, if they give you this, let's draw this. 90, question number 10. If they give us something like this, and then we have the diameter, a line passing through the center of the circle. Are you there?
Yes.
Okay. A line passing through the center of the circle. A line passing through the center of the circle. That's the diameter. And then we have another angle here. Oh, sorry. This one went overboard. Then they tell you this angle. They say, what is angle O? They ask you, what is angle O? If they give you a question like this, just like this, they say, well, find angle at the center. Find angle O. Angle O. So what will it be? So remember the rule, angle at the center is twice the angle at the circumference. So this is the angle at the center, this one, this angle. Okay, this one is 90 degrees. So angle at the circumference is 90. Therefore, the center will be 2 times 90. Remember, angle at center, angle center is twice circumference. Angle center equals 2 times angle circumference. Angle circumference. Equals 2 times angle circumference. So our angle at the center is 90, right? No, angle at the center we don't know. We can call it y. So I can call here y. Angle at the center. We don't know the value. And the angle at the circumference is 90. So we say 2 multiplied by 90, which is the angle at the circumference. 2 multiplied by 90 will give us 180. So angle at the center will be equal to 180 degrees. Angle at the center will be equal to 180 degrees. Okay, so this is one application how we use this angle at the center equal to twice the angle at the circumference. Is that okay? Let's find another one, another application for angle at the center equal to angle at the circumference. Okay, this one, they give us a question like this. They give us a question like this, and then they ask us to find probably angle x. Okay, so let's draw this. Question 11. Okay, so sorry, I was trying to plug the computer. So we have here 150 degree angle at the center, standing on this arc. Angle at the center is 150 degree. So here I have 150 degree. Here I have 150 degree. $150. Here they give us x. Okay. And then here I think they gave us 60. Okay, so what we can do, we already know that angle in the center is twice the angle at the circumference. So we call here y. And this O angle and the circumference, not only x and this remaining space, okay, will be 150 divided by 2, which is 75. Right? 150 divided by 2, the whole of this is 75. And then we can find this angle on this side. 360 minus 150, we can find this angle. Okay. First of all, we come here. Angle at the center is twice the angle at the circumference. So we can find the angle here, this angle. Okay, this angle will be 75. So we can find this angle, this one, by saying 360 minus 150, which gives us 210. We already know here to be 60. We know here to be 210. We know here to be 75. So we can find here as well by calling it a quadrilateral. 1, 2, 3, 4. So if you add 60 plus 75, 60 plus 75 plus 210 plus, I can call here A, angle A. A plus 60 plus 75 plus 210 is 345, right? A plus 75 plus 60 plus 210 plus 210 equal to 360. Angles in a quadrilateral. So if you add this and this together, you get 345. So you say A plus 345 is equal to 360. Is equal to 360. So take it away from 360, 345 minus 350, you get 15, right? So angle A will be equal to 15. this angle. So we know virtually everywhere, we know this angle, 75. We know angle A, we know angle 60. But the part is that they want us to find, why did I find angle A? They want us to find angle X. This is a radius, this is a radius, and this is a triangle. Angle A equal to angle X, the base angle of the two radius. A triangle in a circle, when there's a triangle made by radius, the two base angles will be equal. The two base angles will be equal. So angle X equal to 15. Angle X equal to 15. That's so true because 75 minus 60, because here is 60. You know why? If here is 60, only here has to be 60. But let me show it with red. Only this place has to be 60 because they're both bounded by radius, these two radius. If here is 60, here will be 60. And if the whole is 75, 75 minus 60, you can just get X to be 15. Another easy way of doing it. The easy way of doing it, get here to be 75. Angle at the center equals twice angle at the circumference. So 150 divided by 2, you get 75 here. We get 75 here. Now this 75, here is 60, here must be 60 because base angles. The base angles made by radius. The base angle made by radius. So since the radius are equal, the base angle will be equal. If here is 60, this place also will be 60. And you already got the whole of this to be 75. So 75 minus 60, you get X remaining to be 15. X will be 15. So meaning you can simply say, another way is simply to say X equal to 75 minus 60. X equal to 75 degree minus 60 degree, which will give you 15 degree, 15, 1, 5, which will give us 15 degree. So X equal to 15. So I've done it with two ways. The first one was a longer process, but the second one is a shorter process. Okay, X equal to 15. This X is 15. How? Because they both stand on the same chord, or the same arc, sorry. They both stand on the same arc. Angle at the center, this angle at the center, is twice whatever is here. So to get what is at the circumference, which is the whole of this, to get it, you divide this one by 2. You say 150 divided by 2. To get the angle at the circumference, you say 150 divided by 2. So you get this one. So it will be 75. Now since here is 60, here must be 60 because they both have this radius and this radius. So the base angle for a radius equal to the base angle of this radius. So here is 60. If this place is 60, this whole 75 minus 60, you get X. X will be 75 minus 60. So that's for this question. Is that okay? That's for this question. X has to be. See, here is 60. Here must be 60. Okay, even likewise here, it will be 60. So, and here is 75. Okay, 75 minus this, you get 15. That's how they found S to be 15 degree. X is 15 degree. Whichever method they use, or whichever method anyone uses, X must be 15 degree. Okay? Okay, we try. Okay, this comes to the end of this. I let you write. Let me let you write so we can end it for today for this one. Okay? Let me use the remaining few minutes for you to write. See these last three questions, question 9, 10, and 11. Can you copy them quickly in your notes?